So, guys, I wanted to talk very briefly about something that's kind of concerning in Calculus 2, and that's writing style. I see this is unfortunate, but sadly it does happen to a lot of my friends and my former classmates. And that is not switching the bounds of an integral. So basically, like if you guys know the substitution method, you basically, you say u is equal to some function related to x, but then what students do is they end up carrying the old bounds of the integral. They end up getting the final answer right because they keep having the same integral, but then the teacher takes off 1 or 2 marks because like the writing style is incorrect, it's not true. So it's very important to change the bounds and keep the writing style. So let me give you an example. Let's go with a very simple example, one that you might be very familiar with. So let's go with from 0 to 4. Let's go with 2x over x squared plus 1, okay, dx. Let's say we're integrating this function. It's very obvious that the antiderivative is it's very obvious that the antiderivative, not to you, but to me it is, it's ln, I'm not going to use the absolute values because x squared plus 1 is always positive. Ln of x squared plus 1 from 0 to 4. And this is just ln of 17 because ln of 1 is 0. Okay, but let's say you didn't do this. So let's say you end up doing the U substitution. So let's just copy the old question here. And so 2x, x squared plus 1 dx. So like, let's say you weren't able to figure this out right away. You would say u is equal to x squared plus 1. And du is just 2x dx. Yeah. Okay, this is the wrong method. I'm going to write wrong here. It's wrong to say that this is equal to just say is equal to du over u for 0, and then say that's equal to ln absolute u from 0 to 4. And then say it's ln of x squared plus 1 from 0 to 4. No, like, you know what's, because this is actually not true. This value and this value do not have the same thing. So this is wrong, actually. So what you're supposed to do is you're supposed to carry the bound over. So let's do it the right way. So right is, here's how you do it the right way. So you see this. So you say u is equal to 2x is equal to x squared plus 1. You already know that du is 2x dx, so I'm not going to write that. But then, okay, so from 0 to 4, 2x over x squared plus 1 dx. You can do the U substitution, but what you do instead is this. So let's just say you wanted to do your U substitution. So we're gonna leave this blank first. the bound is just du over u. But we have to change the bound. So like this. So 4, here's how we do it. So originally it was 4. So 4, it goes like this. So x squared plus 1, 4 squared plus 1 is equal to 17. And 0 is just, you replace it with put 0 into the u of x. So that's 0 squared plus 1, which is equal to 1. And then it's from 1 to 17. And then you get ln 17 when you plug. So this is the right way to do it. The calculation might be right, but the way you write things is very, very important. I cannot stress this enough. To bring home my point, let's do one more example of this. Let's just clear the whole thing. Let's do, I got this from, okay, let's do 6 pi. From 0 to pi over 2. Sine 4t cos t dt. All right, so the derivative of sine t is cos t, so let's use our u to equal sine t. And yeah, du is cos t dt. Yeah, let's write it down. Du is cos t dt. Okay, so we have this. And now we're gonna plug the U substitution in. So 6 pi. And now we put the u, okay, so 0 colon, so sine of 0 is 0 because, yeah, u of t, so plug that in. Sine of 0 is 0. And pi over 2, sine of pi over 2 goes to 1. So it's from 0 to 1, u4 du, and I already calculated this, that's 6 pi over 5. So that's just what I wanted to say. So I'm gonna write this in big. If you, so you don't have to know how to convert from the U bounds, although it's a little easier in my opinion, but I'm gonna write this in big caps. If you are going to change bounds in a definite integral, either switch the bounds with the U substitution, U sub short, or do the indefinite integral on a separate work area before putting the old bounds with the antiderivative. So that's the main point I wanted to bring, guys. So yeah, thank you very much for watching, and good luck with your math.